Okay, welcome America, welcome India, and welcome Taylor Swift. We are going to be graphing three quadratic functions in different forms. The first one we're going to do is in vertex form, and then we're going to do, I don't know, standard form or something? I don't know. All right, here we go. We are on problem 4 on the worksheet that I hope to attach. Do you guys have this worksheet? We get ready to go? Okay. So this is in vertex form. You can tell the vertex is at HK, so that's going to be at 3, -1, right? So we go ahead and plot that 3, -1, right there. Now we can tell that this is a parabola that opens down. There's a leading coefficient is negative, so it's going to be opening down. All right, so from there, we've got options. We can plot points, but I think it's probably easier if from there, because if you're, let me go back to the beginning. Just y equals x squared. Y equals x squared, right? I'm going to do a t-chart for that. Okay, 0, 0, 1, 1. The next one would be 2, 4, right? So 0, 0, over 1, up 1, over 2, up 4, okay? So for my new 0, 0 is at 3, -1. If I just use transformations from here, and I know it's opening down because the leading coefficient is negative, I can from here go right 1, down 1. And I need to make these bigger because I was reminded about that. And then left 1, down 1, and then I can go right 2, down 1, 2, 3, 4, and down 4, and then draw my graph, okay? Or I can just plot, okay, well, -1. If I plug in -1 for x, I'm gonna get -5, and if I plug in 0, we'll get -2. Plot 2 points on one side of the vertex, and then those points reflect them over the y-axis to get the 2 points on the other side, because it should be symmetric. Any questions on that? Review from algebra. Wait, am I doing the wrong problem?
Yes.
Yeah, where did the -1, -5 come from?
Should I start over? No. Just fix it. You fixed it. I'm on number 4. I was plugging in points from problem 1. I'm glad you guys caught it. Now I don't have to delete
That's
it.
when you do like the 1 over 1 down, 1 over down 3, right?
Yeah.
Okay.
I think it's just easier to use transformations to do it that way. So over 1, down 1, over 2, down 4.
Over 2, down 4.
Right, because of this.
Oh. We do like, that's what Miss Smith taught us, just do like 1, 3, 5.
Yeah.
Okay.
So like over 1, down 1. Over
You
1,
told me
down,
this.
Over 1, down.
I feel like you told me this before. I don't know what you mean by the 1, 3, 5 method, but I'm sure it's the same.
Like to graph, you just go over 1, down 1, over 1, down 3, over 1, down 3.
Oh, yes, that's the same thing. So we're good. Okay. All right. That's how to graph using the vertex form. And this is all review from algebra 2. So it's pretty basic, right? Are we good? Okay. So erasing. Going to number 5. Now, does anyone remember how to graph when you're in standard form? ax squared plus bx plus c. I gotta make sure I've got the right problem pulled up here, and I do. Because we don't have the x-intercepts, right? It's not an intercept form, and we don't have the vertex. So we don't have a place to start. So where are we going to start when it's in standard form? Anyone remember? I know it's been a bit, but there's a formula.
Oh, frick.
This is ax squared plus bx plus c. And the line of symmetry is at -b, x equals -b over 2a. I'm sure you remember now.
Yeah. Wait.
-b over 2a. Line of symmetry. Once you get that line of symmetry down the center, then you can just plot a point on either side. Done. Let's do it. Let's do it. We haven't done it yet. B is -4. So negative b is 4. So x equals 4 over 2 times a, which is -1. So x equals -2. So now, usually I use a highlighter. Is there a highlighter on this new one? No, that's an eraser. Ooh, there is a highlighter. Okay, x equals -2. That's really wide. Okay, it's fine. It's fine.
Sounds like you're passing something. Is that
I
just
draw
like a
it.
straight line?
I draw it like I draw asymptotes. So usually I use the highlighter to do the same thing.
But is it just like a straight line, or is it just like a...
Yeah. I was trying to draw it dotted, but I had never used this tool before. They've changed this tool, and it's just a little too wide. I'm sure I could figure out how to make it thinner, but
Like, try and do this.
we'll figure it out when I'm not recording. But I'm sure one of you guys can tell me. Yeah, because that one's fine. Okay, so now that we've got the line of symmetry, we know the x coordinate of the vertex is on that line. That x coordinate is -2. So what we can do is we can plug in -2 for x. So we can say, what's f of -2? Equals -2 squared minus 4 times -2 plus 5. And we get the point that's on that line. And I am getting number 5, right? I'm getting -2, I'm getting 9. Is that right?
Sure.
Well, you guys better be checking my work so I don't make a mistake here. Okay, from there, use your 1, 3, 5, and you're done. And we know it's opening down because the leading coefficient is negative. Are we good? That's how you graph in standard form.
How do you know what the slope is?
What do you mean?
How do you know what the slope is?
The slope is a word that we use for steepness of a line. This is a curve. So the slope in between any 2 points is going to be different.
How do you know like which one's the closest one?
You mean like how do you find the other points to plot? Well, we kind of just went over 2 methods. You can do, did you have Miss Smith last year? You can use the 1, 3, 5 method. So once you get the vertex, you can go over 1, down 1, and then I usually, well, the way I teach it is over 1, down 1, then over 2, down 4. Like I'm plotting points. I'm plotting points like that's the 0, 0, and I just moved the 0, 0 somewhere else. Okay, and then the last one is the intercept form. And we start in a different place for this type of problem as well, because we can tell immediately where the zeros are, or the x-intercepts or the roots. Those are all the same words for the same thing. So we've got zeros at 3 and -1. 3 and -1. And this graph is going to open up because the leading coefficient is positive. So now we just have to find the axis of symmetry is right in the middle there. Now we can count. Okay, but the way you do that is you average. How do you average 2 numbers?
Add and divide by.
You add them up and divide by how many there are, in this case 2. Right, yeah. So if you want to find the average of 3 and -1, you just add 3 and -1. We just call that P and Q. X equals 3 plus -1 divided by 2. So you might see P plus Q divided by 2. That's what that means. You're just averaging the 2 numbers and you're trying to figure out what's in the middle. We can clearly see that's going to be 1, right? You don't really have to even go through all that. but here's your axis of symmetry. Okay, so that means your vertex is on that line. So if I was gonna draw an XY chart here, my vertex X coordinate is going to be 1. So to find the Y coordinate, I'm just gonna plug it in and see what I get. Remember, there's a 1/2 in front. So if I plug in 1, so Y of 1 equals 1/2 times -2 times +2, and that should be, I have -2, is that right? 1 -2, someone check me on that. There's your vertex, and that makes sense because the graph is opening up, because we've got our other 2 points here, zeros, and that's gonna be graph opening up. And that's really all you need. If you want to plot one more point, you know, you can plug in, you know, -3 and see what you get. You get 6. So you could do that. Is that 6? And then you can reflect it over the line here. It's 1, 2, 3, 4, 1, 2, 3, 4. You could do that. That's it. Done.